Hello everyone, this is Gayatri Chilukala. Today I'm going to present neural networks for information retrieval. Why did I choose neural networks is that it performs various tasks because unique capability, particularly in handling complex high dimensional data and learning the different types of patterns like pattern recognition, whatever the nonlinear relationships like feature extraction, like automatically learn the hierarchy features from the raw data and scalability. Modern neural networks are like highly scalable and then can handle vast amount of data, which increases the importance in the field like big data and artificial intelligence. It can adapt to the various domains like healthcare, finance, versatile in doing any kind of task. So, in short, neural networks are the powerful for tasks where traditional algorithms may struggle, especially with the complex that requires the sophisticated learning of patterns and relationships. So, in this presentation, we will explore the current applications of neural networks in modern IR systems, where we can highlight the benefits, challenges, and future directions in the neural networks. Coming to the next slide. What is introduction to the information retrieval system? Introduction to the information retrieval system, we are having the first search. So the IR system analyze and search through vast amount of data to identify the information that matches the user need. They aim to return the results that are relevant and useful based on the query provided. So, whenever the user enters an input, the input system processes this query to understand what user is looking for. This involves in analyzing the words in the query, understanding the context, determining how they relate to the information stored in the system. Written whatever the processed query, the IR system retrieves and presents the most relevant results to the user. These results may include documents, web pages, and other types of data best match the user request. Coming to the indexing, the efficient storage and retrieval of the document is very crucial in information retrieval. Indexing structures optimize the search speed. Whenever you are indexing it, it is obviously your whenever the search results will become more efficient. Ranking results are ordered by relevance. Algorithms determine the most useful information for the user. And the information retrieval systems, whenever the user submits a query, the system processes the information and returns the results that are ranked according to the relevance to the query. Relevance refers how closely the context of the document or the data matches the user request or the intent. Coming to why do we choose neural networks in IR? What happened to the traditional methods and what are the limitations for that? Coming to the Boolean model are treats the documents either it's like relevant or irrelevant. There's even a middle or the median stage where it is like partially relevant also. So there is no gradation of relevance which may be a problematic or some documents may be partially relevant. So simple but rigid, it cannot rank results or handle partial matches effectively. Vector space model is like independent of each other. In terms, we can say that the presence of one term does not affect the presence of another. This independence is often unrealistic. So it struggles to understand the semantic understanding and word relationships. Coming to the probabilistic model, it assumes that distribution of terms in documents and independency of document relevance. See, it's like more advanced yet still limited in capturing the language, nonsense, and context. Coming to the next one, we have fundamentals of neural networks. We have different. What is exactly neural network consist? It consists of neurons, the data, the input data is taken as a neuron. So we have layers like input layer, output layer, and hidden layer. Whenever the data is given, it's given as the input layer, and then it passes through the several hidden layers. Then we have the output layer where the prediction is mirrored, no label is mapped, or the category is mapped. So, coming to the activation functions, these introduced nonlinearity, allowing the network to learn complex patterns and relationship. So, coming to the next slide. So, the neural networks architectures for IR. So, it's like feed forward networks, convolutionary networks, and recurrent networks. These are the three networks. We'll try to explore them independently now. Feed forward neural network. Coming to it is like simple architecture, like basic IR tasks or information flows in one direction. In the feed forward, it's like an artificial neural network where the information only flows in one direction. So from input to output without cycles. It consists of input layer, one or more hidden layer, and an output layer using weights, bias, and activation functions to learn the patterns. When a it's simple and versatile task like classification and regression can be performed as part of the application. There are like several foundation models in machine learning paving the more advanced architecture that we have seen, like convolutionary neural networks and recurrent can be the advance of this feed forward networks. But in feed forward networks we have regression and classification applications. Let's take an example of an example how the text classification works using the feed forward neural network. So we are given an input. It can be any kind of text data. Suppose when we take an example of text data, whether it's COVID positive or negative or something like a text data that we have, and next the text is converted into the numerical vectors. Like if it's given I love information retrieval. This is converted into the numeric data. It's mapped using the word embeddings because the machine understands only the numeric data. So it is converted into word embeddings using the predefined functions in Python and multiple layers like learn hierarchical representation. We have multiple layers where different patterns and recognitions is done in the processing step, and final output is predicted. It can be a category, it can be a label, it can be any topic based on the given input. Suppose a statement is given that the product review is bad. This can be a positive or a negative. So this is a positive review or a negative review. The output is predicted using the feed forward neural network. This is a text data, right? So this is one of the example that we can take. Coming to the convolutionary neural networks, in convolutionary neural networks, it's like an ideal for processing the structured data, effective for image and text classification, especially. So you have the convolutional layers and pooling and image processing. In convolutionarily, I like this specially designed for like structure grid data such as images. They use convolutional layers to automatically learn or detect the local patterns and features in the data. So next is like pooling. You have max pooling, min pooling, average pooling, and different types of pooling where the dimensionality reduction of the data is taken. Whenever we take an example of max pooling, it could be like 1 2 3 4 2 into 2 matrix. When it is converted as max pooling, the result is 4. And when we take the example of the min pooling, the result is 1. So it's average pooling. It's going to take average of all the four numbers, and the data is going to be reduced. So when we take an example of a picture, it is like 500 into 500, and we can reduce the dimensionality of the picture, especially in the convolutionary neural networks using the pooling technique. So this is like, as I told you, its application would be an image based task crucial for visual identification and information retrieval. So their architecture like involves poolings and etc, as I explained you. So high dimensionality data will be like computationally complexity. It's like high complex data is reduced using pooling, and this is how the neural network on CNN works. Next, when we take an example how the information image retrieval works, like it will extract the visual features, reduce the dimensionality, and generate the image embeddings. When we take an example like a place of an airport where there are vehicles recognition, so the minute vehicles are also being recognized. How this is done is using CNN layers. The last one is the recurrent neural networks, which are designed for processing the sequential data by using the previous outputs as inputs. for current computations, allowing them to capture temporary dependencies. They are partially effective for tasks like time search prediction, language modeling, and speech recognition. However, RN also faces some issues or challenges such as vanishing and exploding gradients during the training, especially with the long sequences. So you have the memory, time series, and language. These are the three main things. Like in our, it will maintain an internal set, allowing them to, because based on the previous state or anything, it's gonna be determined. And the time series, like ideal for task involving time dependent information, language, like it's a powerful NLP and text based information retrieval. So recurrent neural networks for like sequence to sequence learning. In encoder, it's like it is going to process the input sequence, capturing the context and meaning, and the internal state. It will maintain a compressed representation of input, and the decoder is the last one. It generates the output sequence based on the encoded information. So we have like several models, as we, it's like combining all the network architecture like hybrid model. In normal classification techniques also, like random forest, decision tree, SVM, we can all combine the models using like voting classifiers and stacking classifiers. In the same way, in the neural networks also we can build classifiers in the hybrid model. How can we, it's called as a multi-model retrieval, where we can combine the CNN and RNN for the image test search tasks. Attention mechanisms is the second step. It will enhance the performance by focusing on the relevant parts of the input data. The transform learning is like it's a pre-trained networks to improve the results on the specific task. So we can build it the same way as the normal classifiers like hybrid models, and even in the neural networks for the information retrieval. Coming to the word embeddings and some semantic representation, as we explored that the input data is in the form of text and it has to be converted into the numerical embeddings, that is using the word to vector. So this is creates a word vector representation of words, captures the semantic relationship between the terms. As we know, there's a model which has a VSM model which has a disadvantage that it's not able to capture the semantic relationship between them. So we can convert the word to vector which is having the semantic relationship along with it. Next is global vector. It's Globy is the Python library that we are going to use to convert into the word representation. It combines the local and global statistical information. And the last one is the BRT model. It's like a bidirectional encoder representation from transformers. So this BRT model can be used for several classifications. Especially in the text classification, we can use the BRT model. When we take an example of the fake news detection, whenever a sentence is given, we can take the BRT classifier and classify the text. How does the BRT work? It's like the BRT has several layers in it. So first we have the token embeddings, position embeddings, and then finally we produce the output in the BRT model. So BRT model is especially used for text classification. And next, when we take an example of the neural ranking models. In the neural ranking models, we have the input pre-processing. Queries and documents are converted into the numerical representations in the neural networks. This enables the neural network processing. In the feature extraction, neural networks automatically only will take the relevant features, learn the relevant features. It will reduce the need for the manual feature engineering, because in the manual feature extraction process you are going to do a lot of things, which are the columns that are not necessary and which has the null columns, and everything is removed. So in the neural networks, it will automatically only learn the relevant features. Relevance scoring is like the network computes the relevance score and the documents are ranked based on this scores. So in neural IR, like for query expansion and relevance feedback, in the query expansion is like whenever you have the suggested related terms, it broadens its search and improves its recall. When it comes to the relevance feedback, user interactions refine the results. So whenever a user is providing us a feedback, based on the feedback, the model is re-ranked, and also it will store the results of the feedback so that it doesn't give the or doesn't train in the same way that is trained before. It will correct its mistakes. So neural networks learn from the feedback to improve the future search. So in the traditional search, if the user inputs a keyword, the system may look or exactly close match it and it will produce the result. However, to improve that, the relevance information due to the ambiguity or synonym usage, neural IR model, especially those like helps to identify the related terms. So the contextual expansion like model will analyze the context in terms of used, helping it add more precise expansion. So in this process, the document, while the documents user marks are relevant or irrelevant, it marks the documents are relevant or irrelevant. So user feedback integration helps a lot. So embedding space adjustment, neural networks represent the queries and documents in dense and multi-dimensional embedding space. As a feedback is gathered, the system adjusts the position of the relevant documents closer to the query in the vector space, ensuring the final future results are better. So this will have an handling complex queries, improving precision, dynamically adjusts results based on the user feedback. These are all the things that it does as part of the neural networks query expansion and relevance feedback. Coming to the applications in IR, applications in IR is like first one is search. Search, neural network improves the search engine accuracy and relevance ranking. So when we take an example, we have like recommendation systems also, personalized content suggestions based on the user behavior and preferences. So we have in the before slide, we have taken the relevant feedback from the user and then the model is trained. So this can be taken as an example for recommendation system. And classification, automatic categorization of documents and images. When you take your Google Photos, it is going to categorize like based on the photo background. It will categorize this is the place that you traveled and these are the photos related to this place. So this can be a classification example. And recommendation system is like it gives you recommendation based on the input that you're giving. Suppose you're entering that it's like Anaheim, California, and then it's gonna give you the related. When you click on hotels or motels, it will give you recommendations based on that. So we can also take an examples like computer vision, image and video recognition, object detection, and etc. There are several other examples also. It is applied in healthcare, finance also. So evaluation metrics and benchmarking. So we have like four metrics. One is precision and recall. So they are like high quality results must be needed and comprehensive search is required for recall and precision. So based on the recall and precision, F1 score overall assessment is overall performance is tested. NDCG is like ranking the quality measure by evaluating the results order that we got. The challenges is like interpretability, making neural IR models more transparent will help and understand improving the decision making process efficiency in the future directions with like reducing the computational cost, a faster crucial real world applications and multimodal IR integrating text, audio, images, everything will create more comprehensive and versatile search capabilities. So we can also take another examples where it is really applied is like healthcare. It can be used in diagnosis, drug discovery, and personalized treatment recommendations, and also can analyze the medical images, predict the patient's outcome, and assist the genetic research. In finance, like fraud detection, algorithm trading, credit scoring, risk management, it will analyze the transactional data for anomalies and predict the market trends. And also autonomous vehicles are the latest one. It's like object detection, path planning, decision making in real time. Neural networks play a very critical role in self-driving cars to perceive and respond to the safe environmental. So we can also take an example of the recommendation systems as I explained you before, like e-commerce websites, streaming platforms, social media, like providing the personalized recommendation based on the user. That is, if he is watching more comedy series or thrillers, it will be recommended in that way. The content is displayed whenever in the homepage based on the user's previous watch or previous feedback. This is how neural networks works in the field of information retrieval. This is about my presentation. Thank you very much.